Okay everyone, we are going to continue with a bit of work on calculations, but to answer the next question we're going to revise a small section of crude oil which is on your mock exam. So we should know that crude oil is a mixture and that mixture of compounds that make up crude oil are mostly from a family called the alkanes. Now all of their names are going to end in "ane", and you'll know some of these compounds, for example, methane, ethane, propane, and butane. And you should know these names. You need to know the formulas that match up with them, and if you see the formulas, you'll notice that as we write them, the carbon and the hydrogen are going up in the same proportion each time. So for every carbon that I add, I'm adding 2 hydrogens, and they form a homologous series. So we talk about a series of hydrocarbons. They're hydrocarbons because they're only made out of carbon and hydrogen, and they follow a pattern where they all have the same proportions, and we can say for every n carbon atoms there will be twice as many hydrogens plus another 2. So look at these formulas. 1 carbon, 1 times 2 is 2, plus 2, 4. 2 carbons. 2 times 2 is 4, plus 2, 6. 3 carbons. 2 times 3 is 6, plus 2 is 8, and so on. So that if we had an alkane with, for example, 9 carbon atoms, we could use this formula to work out how many hydrogens it would have by doing 2 times 9 is 18, plus 2 is 20. So, key fact number 1, crude oil is a mixture of hydrocarbons. The hydrocarbons are molecules called alkanes that all belong to the same family and have the same general formula, which is here. Okay, next. Once we know the formula, here's ethane, we could also represent this as a display formula, 2 carbons and 6 hydrogens. These sticks are representing the bonds between the individual atoms, and you can see that this compound follows our rule for carbon, so that carbon always makes 1, 2, 3, 4 bonds per atom. So when you're drawing these formulas, each carbon atom should have 4 sticks coming out of it. Hydrogen has only got 1 electron, so it only makes 1 bond. Let's do another one. Let's do butane, which is C4H10, 1, 2, 3, 4 carbons. Join them up, add the hydrogens, count the hydrogens to check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our alkane molecules. And finally, on this little bit of revision, when we're writing our series then, ethane, propane, butane, you must know those formulas, you must know their names, but we could keep going, adding to our series in the same proportion, and the key fact about these molecules is as they get larger and larger, their boiling point gets bigger and bigger. So we might have gases and then start to move into liquids, because as the boiling point increases, once the boiling point is above room temperature, things will be a liquid at room temperature. So the boiling point increases in this way. Okay? At the top, the very smallest molecules, they are going to be the most flammable. They burn the best. They're going to be the most volatile. They've got the lowest boiling points and evaporate easiest, and they will be the least viscous. So where they are liquid, they will be very runny. Okay, let's look at this exam question. So hopefully you can see this reasonably well. Make it a little bit bigger. And we've got a table here, and the table is saying 4 hydrocarbons, a missing formula and some information about boiling points. All right, and the first job is to work out the missing formula here. So you've got C4, C6, C7. This must be the one with 5. So we're going to put in C5, and we know that the hydrogens will also go up, and we can write that in. Let's make it smaller. Okay. Okay, so we're saying, what's it going to be? Let's work it out first. C5, the H is 2 times 5 plus another 2 is 12. Or we could see that it goes up by 2, up by 2, up by 2. At the same time as the carbon going up by 1, up by 1, up by 1. Follows the same pattern. So we've got C5H12, there it is. It would be called 5-pentane. Okay. The next part asks you about a ratio. We know what a ratio means. It's like how many of those to how many of those. Hydrocarbon A, I'm going back to my table to have a look. He says, here it is. Hydrocarbon A is C4H10. That tells me that for every 4 carbons, there are 10 hydrogens. So I could write my ratio like that, 4 to 10, but I need to simplify it to make it 2 to something. Look what I've done. I've halved the 4 to make a 2. I need to halve the 10 to make a 5. The simplest whole number ratio is 2 to 5. Here's our answer for the next part. Okay, the simplest ratio, 2 to 5. Which hydrocarbon is a gas? Think what this means. If you're a gas, it means you've already boiled. It's telling you that the room temperature is 25. And so we go back and we look at these boiling points. Which one would be a gas at room temperature? It's the one that's boiled. So at 25, imagine a number line. If we're coming along at 0, this one is boiling. boiling, 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 boiling. At 25, none of these have boiled. So hydrocarbon A is the only one that would be a gas at 25 degrees C, because it's the only one with a boiling point which is lower than room temperature. Hydrocarbon A is the smallest, it's got the lowest boiling point, and it would also be the most flammable, the most volatile, and the least viscous. Okay, this next question is asking us about what happens when hydrocarbons burn completely. Okay, think what you already know from this question. We got a word in bold, so that must be important. We know that hydrocarbons are only made of hydrogen and carbon, and we know that combusts means to burn, and burning is requiring oxygen. So when a hydrocarbon burns, the hydrogen can react with oxygen and the carbon can react with oxygen. When hydrogen reacts with oxygen, you end up getting water, H2O, and when carbon reacts with oxygen, you get carbon dioxide, CO2. This word is important because if there wasn't enough oxygen, and it didn't completely burn, then you wouldn't get this, you'd get carbon monoxide instead. So incompletely combusting would produce carbon monoxide. The two correct answers then, the hydrogen burns and becomes water, and the carbon is oxidised and becomes carbon dioxide. Finally here, we've got a displayed structure of a hydrocarbon molecule. We're being tested that we know the matching name. We know by counting the atoms here that it is made up of C3H8. I see the C3 bit, and I know that 3 carbons means my name starts with pro, and it fits with my alkane formula, it's propane. I need to tick this box. Okay, last bit. We're just working out the formula of the hydrocarbon. We were talking about C3H8. Like we did in the last video, we've got hydrogens and carbons. Look at the formula. We've got 3 lots of 12 plus 8 lots of 1. 3 times 12 is 36. 8 times 1 is 8. 36 add 8 is 44. Remember, no unit. We don't need to put a unit on here. Okay, that's the end of this video.